Welcome to my YouTube channel. So in the previous lecture, I have discussed matrices, determinant, and some basic properties, elementary row operations, and many more things. If you did not watch, please watch the previous lecture first and then watch. I will discuss today system of linear equations, and first we discuss Cramer's rule. So using Cramer's rule, we will solve the system of linear equations. Let us consider a system Ax equal to b, where A is square matrix. So whenever the system will be of n linear equations in n unknowns, that is n equations and n unknowns, then we can apply these Cramer's rules, because in this rule we have to find determinant, and the determinant only exists for a matrix if the matrix is a square matrix. So here A is the square matrix n cross n, x is the n cross 1. So whenever we multiply, so this n, so by multiplying we get b matrix, which is n cross 1. So this is column matrix and this is also column matrix. So we solve this system of n linear equations in n unknowns. Unknowns x1, x2 dot xn. We have to find this. So here this matrix is denoted by aij, that is n square matrix, and b is a column matrix, that is column vector. So b1, b2 dot bn, n plus 1, and x is the unknown. We have to find this vector x, column vector, that is we have to find x1, x2 dot xn, where this is a column matrix. Let us define ai be the matrix obtained from this matrix A by replacing the ith column. This is important, ai, and we replace by replacing ith column of this matrix A by the column vector B. So we will discuss how we find ai. So ai would be the matrix obtained from A by replacing ith column by this vector B. So if we replace first column by this column vector B, then the new matrix is A1. So if we replace ith column of this matrix A by this vector, then we get ai matrix, and we define the determinant for the original matrix, that is coefficient matrix. Here this matrix is called coefficient matrix for the linear system of equations. So D be the determinant of this coefficient matrix, and the Di is the determinant of ai, that is D1 equal to determinant of ai, D2 equal to determinant of A2, and Dn equal to determinant of A. We represent in this way. So let us see how we make ai. So let us take this is a matrix a11, a12 dot a1i, that is ith column. This is ith column. So this is the ith column, and this row, and this last nth row is an1, n2 dot n I ann. So if we replace this ith column by this b1, b2 dot, then the new matrix is called ai, and that would be 1 1 2 1. This will be same, n1 1 2 2 2 dot a n2, and we change this ith column by this b1. So there is a component b2 dot bn, and the others are same, that is 1n 2n dot nn. So we replace this ith column by this b vector. So we call it ai, and we define di as determinant of this ai. So 1, it will be a1, so we replace first column. So in this way we find ai. So now we discuss one theorem. Let us discuss one theorem. The theorem says that the system Ax equal to b, A is square matrix, X is column matrix with n rows, B is column matrix with n rows, has a solution if and only D not equal to 0. So D is the determinant of this coefficient matrix A. In this case, the unique solution is given by in this manner. So X, we have to find X, which is x1 dot xn. So x1 is given by x1 equal to d1 by d, where d1 is the matrix obtained from A by replacing first column with this matrix B, which is nothing but a column vector. So if we replace first column of A by this vector, we get the matrix A1 and the determinant of A1 is D1. So in this similar way, x2 will be d2 by d and dot dot xn equal to dn by d. This theorem is called Cramer's rule for solving system of linear equations, n equations with n unknowns. We can solve the system of linear equations by Cramer's rules if the system is with n equations and with n unknowns. So now we solve a system by this rule. So it will be clear. Solve the system using determinants. That means by Cramer's rules we have to solve this system of linear equation. So this is system of linear equations with n equations and n unknowns, that is x, y, z. So this system of linear equation can be represented as a into x equal to b. So here n unknowns, that is n equal to 3. So this will be 3 cross 3 matrix, this will be 3 cross 1 matrix, this will be 3 cross 1 matrix. So from this system A will be the coefficient matrix. So write first coefficient of x, y, z in this first row, that is 1, 1, 1, and in the second row coefficient of x, y, z of the second equation, that is 1, minus 2, minus 3, and third row coefficient of x, y, z in the third equation. So 2, 1, minus 1. So this is A, and x is x, y, z, and b equal to 5, minus 1, 3. So this system can be represented by this form, matrix form, where A is this, x is this, and b is this column matrix. So note, I have to remove this to solve. X equal to b, the given system become x equal to b, where a, b, x are given. So first we find determinant of the coefficient matrix this. So from this we find determinant 1 into this 2 minus minus plus 3 minus 1 into minus 1 minus the plus 6, and this will be plus 1. So 1 minus is a plus 4. So this will be 5, this plus 5 minus 5, and this is plus 5. So answer will be plus 5. So now we replace first column of this coefficient matrix by this vector b. Then we get d1. So this will be 5 minus 1, 3. So we replace first column and the remaining two column will be same. So from this we find, so this will be A1. We have to find D1, that is determinant of this matrix. This will be 5 into 2 plus 3 minus 1 into 1 plus 9 plus 1. So 1 plus 6 minus 1 plus 6. So this will be 25, 10 minus 10. This is plus 1, so plus 5. So 30 minus, this will be 20. Okay. So note that, I will remove it. So D1, so note it, D equal to 5, D1 equal to 20. And now we make A2, that is we replace second column by this. So first column remaining same, second column will be 5, minus 1, 3, 1, minus 3, minus 1. And from this we get D2, that is determinant of A2. So this will become 1 into 1 plus 9 minus 5 into minus 1 plus 6 and plus 1. So this is 3 plus 3. So this will be 10, 3 plus not 3. So this will be 1, 3 plus 2. So 10, this will be plus 5, minus 5, so minus 25, and this will be plus 5. So 15 minus 25, that will be minus 10. So D2 is minus 10. Okay, and if A3 become we'll change, replace third column by b vector. So 1 1 2 1 2 1, first two column remain same, third one will be 5 minus 1 3. So determinant of this matrix d3 will be 1 into minus 6 plus 1, minus 6 plus 1, this will be minus 1 into 3 plus 2 and plus 5 into 1 plus 4, 1 plus 4. So this will be minus 5, this will be minus 5, and this is 5 5 25 plus 25. So this will cancel, sorry, minus 5 minus 5. So this minus 5 minus 5 minus 10 plus 25, that is plus 15. So d3 will be plus 15. So if you want to note, you can note down. So by theorem, if d1 d2 dn be the determinant of the matrix a1 a2 dot dot an, which is obtained from a by replacing ith column of this matrix by b, then x1 equal to d1 by d and dot 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 xn equal to dn by d. So in this example, x1 equal to x, x2 equal to y, x3 equal to z. So this will be d1 by d, that is d1 equal to 20, d is 5, so this will be 4, and in this case d2 by d, so d2 here minus 10 divided by 5, so this will be minus 2, and this is z, so this equal to d3 by d equal to d3 is 15 by 5, so this is 3. So the solution x y z equal to 4 minus 2 3. So this will be the answer, 4 minus 2 3. So this is very important question for the students of IIIT Bhagalpur. This is a previous year question. For better understanding, you can take d1 as dx, that is when you replace the first column, as these first column are all coefficients of x in given three equations. So when we replace first column, you can denote the determinant d by dx. If we replace second column, that is d2 can be replaced by dy, you can denote dy, and d3 can be denoted as dz. As in our case, the unknown is x, y, z. So then we get dx by d equal to x, y equal to dy by d, z equal to dz by d. So it will be looking nice to understand or to remember the formula. So that's it. If you can note, you can note. So I will give you exercise to solve by yourself, and if you can send me that homework, you can send me in my email, that is Subarna math@gmail.com. So you can send me in this mail ID. So these are two problems solved by Cramer. So this is simple as the example, and this is the same, but you have to arrange this system of equation as like this and then solve. So if you are interested, you can send me in this mail. So for today, that's it. If you like it, please subscribe my channel and share with your friends. So it will be very beneficial, especially for the students of IIIT Bhagalpur. Thank you very much. Share with your friends. Let them benefit them also. So thank you.